Another way to measure distribution is quantiles. Quantiles are the boundaries or cutting points which divides a dataset into equally small parts. The most commonly used quantiles are quartiles and quintiles, deciles, percentiles. Quartiles are boundaries that divide the data set into quarters. For example, the first quartile is 1/4 or 1/4. That means 1/4 of the data falls below this boundary. 3/4 or 75% of the data in the data set fall above this boundary. Quintiles boundaries that divides the dataset into 5 parts. As an example, the second quintiles, because we have 4 parts, so we have 4 boundaries. 4 boundaries divides a dataset into 5 parts. The second quintile is 2/5. 2/5 is 40%. So this boundary, 40% of the data lies below this boundary, and 60% of the data in the data set lies above this boundary. Decile boundaries that divide the dataset into 10 parts. For example, the fourth decile is 4/10. 4/10 is the fourth decile. This is a boundary. Actually, it means the fourth boundary. For the fourth decile, 4/10. Actually, it is 40% of the data in the data set falls below this boundary. 60% or 6/10 of the data falls above this boundary. Percentiles. This is the most useful and the most popular boundaries that divide the data set into 100 parts. For instance, the 77th percentile. This is a boundary. This boundary splits the data into lower 70% of the values and the upper 23% of the values. That means this boundary, 77th percentile, is a boundary. For this boundary, 70% of the data fall below this boundary, 23% of the data fall above this boundary. So in our daily life, we usually hear the terminology percentile. Remember, actually, percentile is a cutting, is a cut point or a boundary. Uh, but this boundary have close relationship with percentile because this boundary, a certain percent of the data below it, a certain percent of the data above it. For percentile ring is the percent of data that is less than or equal to the given data item. Percentile is different percentile ring. We sometimes just can do not need to distinguish these two terminology in our daily life. But now we are learning mathematics, statistics. We need to know the difference. A percentile ring is a percentage. Percentile actually is a boundary, is a number. Let's learn how to find quantiles in a data set. First, let's look at the quartile. We have a data set over here, 10 numbers. This is 10 test scores. In order to find the quartiles, remember, quartiles are the boundaries that divide a data set into 4 parts. So we are going to find 3 boundaries. How to find it? The first step is reorganize the original data set. We put the data in ascending order from smaller to bigger. First, we find this data sets the median. How to find the median? The middle value of the data set, because this data has 10 numbers. This is an even number, so the median is the average of 2 middle values. Let's find the 2 middle values here. 1, 2, 3, 4, 5, 6. So it should be these two average plus and over 2. We got 84. The number, the value 84 is the second quartile of this data set. It is a boundary. This is the boundary that divides the data set into 2 pairs. Half of the data fall below this boundary. Half and other half of the data fall above this boundary. Uh, this, the next step we are going to find the first quartile. Uh, for this part, we have 1, 2, 3, 4, 5 number. We find the median of it. It's easy because it is we have odd number side. So this one is the middle value of these 5 data. So this is the first quartile. The first quartile. This is the second quartile. Now we are going to find the third quartile. We have 1, 2, 3. Oh, this 1, 2, 3, 4, 5. 5 number. The median is this one, 88. 88. This number is our third quartile. Now we figure out the 4 boundary, or we figure out 3 boundaries that divide the data set into 4 parts. The first boundary is the first quartile. It is number 78. The second boundary is referred as the second quartile. The value is 84. The third quartile is 88. Percentile. We know percentiles are boundaries divide the data set into 10 or into 100 parts. Maybe it confuses you because we only have 10 numbers, 10 data. How could this data divide how could this data divide into 100 parts? But it is a little bit abstract, but it is understandable. Let's look at percentile from a different angle. Let's calculate the more intuitive problem. If I ask you, hey, my score is 83. What is my percentile? What is my percentile rank? Percentile rank. RANK. Find the percentile rank of the value 83. From definition, percentile rank is just the score for below this uh, this value, the percentage of the score fall below or at this value, but usually we just say the percentage of the data fall below this value. Usually we need to arrange the data set in ascending order, and we need to put an ordinal number to figure out the rank of each data or the position of each data. We have this is a little bit tricky. We have 10 data points, but because these two scores are the same, so the position or the number rank, not percentile rank, number rank, we denote 1, 2, 3, 4, 5, 6, 7, 7, 2, 7 here, 7, 7, 8, 9. So for calculate the percentile rank of score 83, we need to count. Hey, how many numbers fall behind this value? One, we have 4. 4 over how many position or how many ordinal number we have? Is 10 or 9? 9. 9. So 4 over 9 is it's not approximately equals to 44.4%. Hey, let's calculate another score. How about the percentile rank of 88? How many data fall behind 88? Look at it. 1, 2, 3, 4, 5, 6, 7. We have 7. We have 7 data fall behind this. We have 7 data fall behind this. Fall behind this value 88. Stop. Do we have 7? 7 or 6? Because these two values are the same, so we actually only have 6 data fall behind this value 88. So it is 6 over 9. This we are going to calculate the percentile rank of score 88. Okay, 6 over 9 is approximately equals to 6.7%. So how about the percentile rank of 96? 96 by convention, the percentile rank of 96, because it is the highest The score is actually 100%. Now we know how to calculate percentile range. We switch the angle. If I ask you, hi, if please tell me 60%, find the boundary, find the boundary of find the boundary for me for 60%. That means the boundary of 60% is 16th percentile. That means 60% of the data fall behind this boundary. 40% of the data fall above this boundary. But I want to know what is the score? What is the score for the boundary of 60%? How to find it? There is a is a formula. N equals capital N over 100 P. What is this formula mean? N is the position or the ordinal number for the data set. Capital N is the size of the data set, how many data points. P is the percentile rate. So for calculate to find the 60% or 16th percentile, we need to first figure out the ordinal number, a little n is 10 over 100. Actually, this is the 10 data divided by 100. That means boundaries divide this 10 data into 100 parts. The P is percentile times 60. Don't put percent, just use 60. Remember, don't put percent. Actually, this is, we got 6. 6 is here. We got 6 here. The position, N is the ordinal number, the position. So this position, which number falls into this position? 85. 85. So now we know the 16th percentile of this data set is 85. It means 60% of the score is lower than 85, and 40% of the scores is higher than 85.